Let's take an example, guys. Let's define A and B, which are inside a universal set from 1 to 10. So A is defined as 12574, B is defined as 3758. Now let's draw it on a Venn diagram, guys. Let's draw U first. So guys, this is U. Now let's draw A inside this. So this is A. Now let's draw B. So this is B. Now let's add the elements, the entries of each set as well as U inside this Venn diagram, guys. So guys, after adding the entries, it will look like this. Okay. So as you can see here, A element has 1, 2, 4, 5, 7. I have made inside this common region, which is indicating their intersection. Then 3, 8, and the elements which are not in A as well as B, 9, 10, and 6. This I have written the elements of A, B, C inside this Venn diagram. But what will happen if we have to create a Venn diagram and if the number of entries, number of elements in each set are very high? So in that case, this becomes very cumbersome of writing each of the elements in the set. What we do, instead of U, A and B, guys, we will write number of elements instead of the elements. Okay, guys, what I mean to say is, see, this 3 and 8, instead of this, I will write 2. So 2 means number of elements in this region. Okay, guys. Now here 5 and 7 are there. So number of elements in this common region is how many? They are 2. So we will write what, guys? Instead of writing 5 and 7, I will simply write 2 here. Now what about this 1, 2 and 4? If I rub these 1, 2 and 4, I have to replace it by which number? Yes, 3. Now what about 9, 10 and 6? If I rub them, so instead of these 3 elements, writing each of them, I will simply write 3, guys. Okay, and this will be what? B would be replaced by number of elements in B, number of elements in A, and NU. Okay, now as you can see, number of elements in A, if I ask you, it would be how many? 3 plus 2, it would be how much? Na would be 5. Similarly, NB would be what? 2 plus 2, it would be 4. And Nu, as you can see here, it would be the sum of 3, 2, 2 and 3. How much it will be? Nu was 1 to 10 natural number, so obviously Nu is 10 only. So as you can see here, if you add 3 plus 2 plus 2 plus 3, it will be 10 only. So that would be Nu, guys. Okay, so it's like this. So Na is 5. Okay, we calculated Na as 3 plus 2 equals to 5. And then NB is 4. NB is 4. Nu we calculate, we already know it is 10. So what about NA intersection B and NA union B, if I ask you guys? This is equal to what? So guys, So guys, this shaded region represents what? Yes, A union B, which contains how many elements? The sum of 2, 2, 2, 7. So N A union B is 7, guys. Okay. So guys, this represents what? Yes, this represents A intersection B, which is clearly 2. Okay. So guys, this shaded region, which as you can see, these shaded lines, they all are representing except inside A. So this represents what? N of what? N of A bar, guys. N of A bar, because this is region which is not in A complement or A bar. So which would be the sum of what? 2 and 3. Okay, 2 and 3 are outside this region. Okay, so it is 5. So N A bar, this is N A bar region, which is equal to 5. Now let's see. Now guys, if I ask you this shaded region which has two elements, this represents what? So this we can say this is only B, because B NB contains two things, only B and elements common with A, this, which in all makes NB. So this we call N only B, which is 2, and we define it as if you take intersection of A bar, which we did in the previous example, and with B, if you take intersection, this is only B, guys. So N only B in case of two sets is the intersection of A bar with B. Now guys, if I ask you what this shaded region represents in blue, as you can see, this does not include the elements of set A or set B. This region is outside A and B. So guys, this is, we define it as N of neither A nor B, because it is clearly belonging to the region which does not belong to either of them. So we call it neither A nor B. And if you take intersection of what? Yes, if you take intersection of A bar and B bar, and you take what? Yes, intersection, what you will get is this 3. So in this case, the answer is 3. 3 is number of elements which neither belong to A or B. Okay. So this blue lines, they represents A bar intersection B bar, also known as neither A nor B, guys. So guys, if we try to derive a relation between NA, NB and A intersection B and so on, okay, NA intersection B and A union B, guys, in that case, we can generalize it what we discussed in the example like this. So let's draw a result, a formula which depicts a relation between NA, NB, A intersection B, and so on. So guys, here this is NU, this is NA, NB. I have drawn. A is number of elements in A only, or it is A represents A intersection B bar. This is only B. C, I denote number of elements in the common region of A and B, and D, I denote common region in belonging to neither A nor B. Okay. So what is the relation between union, intersection, NA dash, intersection B dash, and so on? So guys, as you can see here, if I ask you what is NA union B and A intersection B from the figure, and what is the value of NA and NB? So as you can see here, NA is the sum of only A and A intersection B, which is A plus C. Similarly, NB would be the sum of only B and C, which is B plus C. And A union B, as you can see here, it is this area, so which contains A, C, and B. So it would be the sum of A plus C plus B, and A intersection B, as you can see here, it is C, this value. Okay, so it is C only. So from these results of the values of NA and B, A union B and A intersection B, what we can derive here is, we will do it like this, guys. A dash intersection B dash will derive also. Okay, A dash intersection B dash is simply D only. Okay, let me write it also. This D is N A dash intersection B dash. It is quite clear. Now A and A union B, let's derive. A plus C plus B, I will write A plus C from here, and B I will write, and I will add and subtract C. Okay, so what happens here is B plus C is, we know, is NB. So and NA is A plus C. So A plus C will replace by NA. B plus C we will replace by NB minus C, which is A intersection B, A intersection B. So we derive NA union B, a result which is quite frequently used. NA union B is NA plus NB minus NA intersection B. Okay. Now here also an A dash intersection, this A dash intersection B dash also we can derive. It is D. So N A dash A bar intersection B bar, which is D, which we can write as A plus B plus C plus D minus A plus B plus C. Now A plus B plus C plus D is NU. This thing A to D is NU, and AU A plus B plus C is N A intersection B, A union B. So minus N A union B n a bar intersection b bar. This is another result. There are other results as well, okay, regarding a bar intersection b and so on. Okay, so these two results we got. Now we know that n only b is a bar intersection b. This is what we did in the previous example. Now a bar intersection b, that is only b, is this much. It is b only, small b. So we will write it as small b, and then we can write it as b plus c minus c. Adding c and subtracting c. B plus c is what, guys? We know that it is nb. C is n a intersection b. So n b intersection a bar or only b is what, guys? nb minus n a intersection b. In the similar way, we can also write n of a intersection b bar to be equal to what, guys? Yes, it is n a minus n a intersection b. So these are another results, okay, that are used not only in set theory but in probability chapter also in class 12th. So guys, the results that are useful are these. N A union B can be expressed in terms of NA, NB, NA intersection B as NA plus NB minus NA intersection B. Similarly, NA bar intersection B bar, that is, we call this as N of neither A nor B. Neither A nor B is NU, that is the total, minus N A union B. Okay. Now the next is NB intersection A bar. This we call as what? This is known alternatively as only B, which is NB minus NA intersection B. And similarly, if it is NA intersection B bar, so this we call as N only A, and it is NA minus NA intersection B. Let's do a sum on these results. If NA is 12, NU is 30, NB is 16, and A intersection B bar is 10. We have to find A union B, N A union B, and A bar, N of A bar intersection B bar. So guys, try this. So yes, we can use the results that we have derived above. Okay. So let's find out an A union B first. Okay. Before that, we will use this. Just a minute, guys. And A intersection B bar, that we will use, equals to 10, and then NA intersection B bar. From this we will find NA intersection B, and then we will use the formula N for A and A union B as NA plus NB minus NA intersection B, because NA and NB are given to us already. So NA minus n A intersection B bar. So it is for A intersection B is equal to 10. Na is given to be 12. So Na is 12 minus 10. Okay, this comes here, this comes here. And A intersection B is 2, guys. So and A intersection B is 2. So we will use the formula for NA union B now, which is NA plus NB minus NA intersection B. So NA is 12, NB is 16. NA intersection B we calculated as 2, 28. This is 28 minus 2 is 26, is NA union B. This is the first result. Similarly, in order to find an A bar intersection B bar, we will use which result, guys? An A bar intersection B bar, we will use NU minus what? N A union B, guys. Now NA union B is 26. NU is given to be 30 in the question. NU is given to be 30 here. So that we will substitute 30 minus 26, 4. So N A bar intersection B bar is calculated to be, its value is 4. Let's take another example, guys. Now, guys, if a Venn diagram is given where NU, NB, NA, they are specified. Okay, the values given are like this, scattered across this, inside this rectangle. Now the question is same, but this is more of kind of figure based question where we have to find the union of A and B, A bar intersection B bar, NB, NU, and A intersection B bar. So guys, NA union B, if you see from the figure, A union B, it is the, it is this this whole area where 7, 3 and 8 are there. So guys, 7, 3 and 8, the sum would be A union B, 7 plus 3 plus 8, 18. Now A bar intersection B bar is clearly, as you can see here, neither A nor B, which is 12. So we can directly say this is 12. Now NB is what, guys? NB is sum of 3 and 8. So guys, sum of 3 and 8 is 11. So that is NB, which is 11. NU is the sum of all this, sum of all the numbers inside this rectangle. Okay, 12, 8, 9, 3, 7. 7 plus 3 is 10. 10 plus 9, 19. 19 plus 8, 27 plus 12, 39. So NU is what, guys? Yes, NU is 39. Now NA intersection B bar, what is the meaning of this? This we know that this means only A. Okay, so number of values in only A is, as you can see, it is this. So n A intersection B bar is equal to 7. That is the answer. Guys, let's take a question, a word problem. Okay, in a hostel, 30% students eat pasta and 55% eats pizza, while 25% eats neither pasta nor pizza. If number of students eating both is 90, find total hostel students. Okay, so this we have to solve. So what should be our approach? What should be the hint for this question, guys? Hmm? So the hint would be, guys, the hint, the approach is, if percentage is given, then what NU, the total percentage that we can assume. So obviously, if percentage they are referring to of hostel students, then definitely the total number of students, which is NU, it must be assigned how much percentage? So yes, it must be assigned 100%. Okay. So from this, we can find NA intersection B. Okay. NA union B, we can calculate, because 25% it is given that 25% eats neither pasta nor pizza. So we can find number of students that eats pasta or pizza. From there we can find students eating both pasta and pizza. Okay, these kind of word problems are also called as cardinality based problems. Okay, that we encounter in sets related questions. So what is A and what is B, that we will see in the solution, guys. So let's assign A as number of percentage in percent, number of percentage of students eating what? Eating pasta. Okay, so B is what, guys? B is percentage of students eating pizza. Okay, guys. Now, as you can see here, 25% students eats neither pasta nor pizza. What is the meaning of this, guys? N A bar, neither pasta nor pizza, is 25%. Okay, A bar intersection B bar they have given. 30% of students eat pasta means what? NA is 30. And 55% eats pizza means what? NB is 55, guys. So from the word problems, from each sentence we can infer various mathematical numbers results. So now n A bar intersection B bar equals to 25. Okay, that this we will use. First, what we will do, we will find out n A union B, which is what in terms of NU minus n A bar intersection B bar, guys. Now, NU is given to be 100% and A bar intersection B bar is guys 25. Okay, A bar intersection B bar is 25, that we will substitute in this. So this is 25. So NA union B percentage came out to be 75. Now what they are asking in the question is if number of students eating both is 90, find total students. So number of students eating both is 90 means what, guys? That percentage we can calculate, which is number of students eating both, is what they are referring to is NA intersection B. This 90 is not in percentage terms, but we can find it in percentage terms from the formula NA union B, A intersection B rather, is NA plus NB minus NA union B. Now NA, we know NA and B will substitute from here. NA is 30, NB is 55, that we will substitute. 30 plus 55 minus NA union B minus 75, which is 10. So NA intersection B came out to be what, guys? 10. So this 10 is not a number of students, this is 10%. And in the question they have given that number of students eating both with NA intersection B is 90. So 10% is equivalent to 90. So 1% is equivalent to 9 students. Now they've asked number of students in the hostel. Number of students in the hostel means they are asking total students, means what is the value of 100%. Total number of students if they are asking means they are asking for 100%. So multiplying by 100 both sides, 900 student is the strength, total strength of the students in the hostel. Okay guys, 900 is the answer. Let's see one problem, guys. A set A is defined such that n is a natural number whose HCF with 12 is 1, and A is a subset of the universal set, which is defined to be a number from 1 to 100, guys. Okay, so now the question is what? So the question is, we have to find number of elements in set A and the sum of elements of set A. Okay, these two things we need to determine from the question, guys. So what should be, so guys, what should be our approach to solve this, guys? What should be, let's try to find the meaning of this. What is the meaning of the HCF of the two numbers A and B? Okay, HCF we have done in lower classes. For example, if I ask you what is the HCF of 2 squared 2 into 3, HCF means highest common factor. So the maximum factor, maximum number that can be taken common from both, as you can see, is 2. So HCF is 2. Okay. So the meaning of HCF of two numbers A and B to be equal to 1, because in the question it is given that HCF of n and another number n and 12 is 1. Okay. So if I ask you what is the meaning of HCF of A and B, so it's quite clear that since it is 1, there is no common factor. No common factor. So HCF in that case is 1 only, guys. So for example, if you take HCF of 7 and HCF of 3 into 4 into 6, so as you can see, there is nothing in common. So answer is what, guys, for this? Yes, answer is 1, guys. So now what is the meaning of HCF of n comma 12 equals to 1? So n comma 12 equals to 1. 12 is made up of 3 and 4, which is 2 square into 3. So it means since it is 1, n is something that it should not be a multiple of 2. Since it won't be a multiple of 2, automatically it won't be a multiple of 2 square. Okay, let's say k1. K1 is some natural number. As well as n should also be, it should also be not a multiple of 3, because if it contains 3, or if it contains 3 or if it contains 2, we can take 2 or 3 common and the answer won't be 1. So in that case, n should be something that it should not be a multiple of 2 and it should not be multiple of 3, k2, where k1, k2 are some natural numbers, guys. Okay, now let's define, in order to solve this, a set B is such that n is a multiple of 2. Set B is a set which contains all the numbers which are a multiple of 2. N is of the form 2k1, where k1 is some natural number. Now let's define another set C as a number which is a multiple of 3. N is a multiple of 3. So n we can write as 3k2. Okay, now why we are defining set B and set C? Because A depends on B and C. What is the relation of set A with B and C? That we will see. So this whole thing is equivalent to what? Now let's define A. Since A is defined in the question that HCF of n comma 2 square into 3 is 1, it means that n is not a multiple of 2 as well as it is not a multiple of 3. So where k1, k2 are some numbers, so this we can say that n is not a multiple of 2, means it is b bar. Okay, and A is not a multiple of 3. So n means intersection. N is not a multiple of 3. If n is a multiple of 3, then it is C. And if n is not a multiple of 3, then it has to be C bar. N is not a multiple of 2, then it has to be B bar. So A has to be what? A has to be B bar intersection C bar. Okay. Now what we need to know, the first part of the question they are asking about NA. So it means since NA is B bar intersection C bar, so we have to find B bar intersection C bar. And from the results that we derived, it is NU minus NB union C. Now the question arises here that what is NU here, guys? Number of elements in U. So as you can see from the question, the universal set that is defined in the question, it is from 1 to 100, 1 2 3 up to 100. So number of elements in NU, it has to be what? Yes, it has to be 100. Now from the formula, NB union C is defined as NB plus NC minus NB intersection C. Okay, so let's say this is first equation. So NA is this 100. If you calculate NB, if you calculate NC, if you calculate NB intersection C, you will calculate NA. So now we will find one by one the value of what? NB. So NB, we already defined numbers of the form 2k. So NB means number of numbers of the form 2k less than or equal to what, guys? Since it is given that A is a subset of the universal set, less than equal to means less than equal to what, guys? less than equal to 100. Okay, so it has to be none other than 2, 4, 6 till 100, which is 2 into 50. So the first number is 2 into 1, the second number is 2 into 2, and so on. So the last number is 2 into 50. So obviously, what has to be a NB? Yes, NB is 50. So NB, it has to be 50, guys. NB is 50. Now let's calculate NC, guys. So NC is what? Numbers of the form. NC is since C is of number of the form. Yes, it is number of the form. N equals to I'm asking a question mark. Yes, it is of the form 3k, guys. Okay, if you haven't forgotten, this is what we defined C to be, 3k2. We defined it. So NC is number of numbers of the form n equals to 3k2, guys, where k2 is some natural number. And yes, it is less than equal to, it has to be less than equal to what? Since A is a subset of the universal set, it has to be lesser than 100, guys, or equal to 100. So NC has to be what? It is of the form 3, 6, 9, 12, and so on. So the question mark means what is the last term which is less than or equal to 100 and a multiple of 3? So yes, it is 99, which is what? Which is 3 into 33. Now the first number is of the form 3 into 1, last is of the form 3 into 33. So what can be NC, guys? NC is 33, guys. So we calculated NB, it came out to be 50. Now we calculated NC, it came out to be 33. Now it's a turn of finding what, guys? Yes, B intersection C. B intersection C means what? Now we know that B is number of the form 2k1, that is the multiple of 2. C is the number of form 3k2, that is a multiple of 3, where k1 k2 are what? Yes, k1 k2 are obviously they are natural numbers and less than equal to what? Obviously they has to be lesser than equal to 100 only, because everything is inside the universal set U. Everything is happening inside the universal set U. So n is a multiple of 2, n is a multiple of 3. It means a number which is both a multiple of 2 and a multiple of 3. It means if you take LCM of 2 and 3, which is 6, it has to be none other than the multiple of 6. So B intersection C, the meaning of this, a number which is multiple of 2 as well as multiple of 3, it is multiple of 6 only, guys. So n equals to 6k. If you see, the first number is 6, obviously 12, 18. So now the question arises, what is the last term which is lesser than equal to 100 and a multiple of 6? So if you think a bit, 16 into 6 into 16, which is 96, which is 6 into 16. 96 is the last number closer to 100 and a multiple of 6. So obviously, n B intersection C is what, guys? N B intersection C is, the first number is 6 into 1, the last number is 6 into 16. So the number of element is NB intersection C, it has to be 16 only, guys. So all the three values of NB, NC and NB intersection C we have calculated, that we will substitute in this equation 1. So 100 NB is 50, this is 33 minus 16. So 100 minus 50 plus 33, you can write it 50, 83 minus 16, it is 83 minus 20, which is 63 plus 4, says 67, guys. The 67, 100 minus 67 is what, guys? It is 33, guys. So Na is 33. Number of elements. The answer to the first question is Na is 33. But the second question, they are asking for sum of elements in A. This is what they are asking in the second question, guys. That we need to find the sum of element in A. The sum of elements in A means what, guys? Now sum of elements, so the same number of elements question, the formula, we can instead of writing the number of elements, we can write the sum of the elements. Like in the previous question, in the previous formula, we wrote Na. So instead of Na, if it is replaced by sum of elements in A, so instead of Nu, it would be replaced by sum of elements in U. And similarly, instead of minus of NB plus NC and so on, so it has to be replaced by sum of elements of B, C and B intersection C. Okay, so that way we can find the sum of elements in A. Now sum of elements in U is, the U is the universal set defined from 1 to 100. That way we will substitute 1 plus 2 plus 100, which is using the formula of AP. There are 100 terms. 100 divided by 2, first term and the last term, which is 100 by 2, 1 plus 100. Okay, that way we will do. Now similarly, the second term, for sum of elements for B, we will add from 2, 4, 6 till 100. So 2, 4, 6 till 100. How many terms are there? 50 terms are there. So the formula of AP is n by 2 A plus L. The first term is 2, the second is 100. Similarly, 3 plus 16 plus 9 and so on till 99. This is another AP having 33 terms, having first term as 3 and the last term as 99. Similarly, minus of B intersection C, which is a multiple of 6, starting from 6 and onwards till 96. Number of terms is 16 and first term is 6. Number of terms is, sorry, the second last term is 96. 6 plus 96. So guys, this sums up to 50 by 2, which is 25. 2 plus 100 is 102. Now 33 by 2, 3 plus 99 is 102 by 2, minus 16 by 2, 6 plus 96. Okay, 16 by 2, 6 plus 96. So guys, this is 25 into 102. Okay, now 102, as you can see here, 102 is common everywhere. So that we will take common. So we would left with 25, 33 by 2 minus 8. Now 25 minus 8 is 17. Okay, now we will take LCM. So 2 gets multiplied here. So 70 into 2 plus 33 and 2 comes out here. So 102 by 2 is 51 and this is 67. Okay, now 51 into 67, 3417. If you subtract 50, 50, which was obtained by multiplying 50 into 101, if you subtract it, you will get what? So you will get 1633, which is what? Which is our answer of sum of elements of A. Sum of elements of A is 1633. Okay, so this is the answer, guys. Now if a question contains, if it only gives the value of Na as 50%, Nb is 35%, where obviously Nu is how much? Yes, it is 100% obviously. Okay. So if they are asking the possible value of NA union B and NA intersection B, now it's quite clear that in order to find A union B, we need to know the value of A intersection B from the formula, or vice versa. In order to find NA intersection B, we need to know the value of NA union B from the formula Na plus Nb minus Na intersection B is equal to Na union B. Now since they are asking, in the question they are asking about possible values, it means we need to consider some cases, some extreme cases, which may give us what? Yes, which may give us, which will which will give us the maximum and minimum value of Na union B and Na intersection B. So this we will discuss today, guys. Okay. We are aware of this general figure, which is this, guys, where Nu, when if Na and Nb are given in percentages, so Nu we will take as 100%. Now this is the general figure where some A and A intersection B is it exists, and obviously A union B and so on exist when there is some intersection where there is some n A bar intersection B bar also exist. So this was a general figure we used to derive certain relations between certain formulas between Na, Nb, Nu, Na intersection B, A intersection B bar, A bar intersection B bar, and so forth. Okay. Now let's consider these cases, like this or this. So these two extreme cases is possible according to what is given in the question, according to Na and Nb percentages. We will discuss these cases one by one. So let's take this case first, guys. Okay. Now Na, Nb, they are separated. They are disjoint sets, guys. It means A intersection B is phi and A intersection B is, in this case, it is 0. So this is one of the minimum values of an A intersection B, we can say that, because there is no intersection, no area common to both A and B. This is obviously Nu, which is, as I said, which is 100%, guys. Now Na in the question, it is given as 50%, Nb is 35%. So Na is 50%. So the area of this circle is 50. We can say this is 35%. So the remaining 50 plus 35, 100 minus 50 plus 35, 15 is A bar intersection B bar. Okay. So as of now, we are concerned only about the maximum minimum of Na intersection B. So Na intersection B, as you can see here, the minimum value is 0. Okay. Now what about Na union B? Na union B would be what? It would be the sum of these two areas. So now we know that N from the formula, Na plus Nb, from this formula, Na plus Nb minus Na intersection B, Na is 50%, Nb is 35%. Now Na minus B, if this is minimum, see, we are subtracting Na plus Nb minus something. So N union B, if this we make it less, which is the minimum is 0. So if we make this less, in that case, n A union B that we will obtain would be what? Yes, it would be max. So in this case, n A union B, that is the max value, would be 85%. So when A union B is max, A intersection B is minimum, we can say in this case, and rather in every case. Okay. So n A union B max is 85 and A union intersection B minimum is 0, guys. So in this case one we discuss. Now let's discuss the second case where this is NU is 100. Now A was 50, B was 35. So this case NA, this 50, this circle, guys, NB circle will draw inside because NB is lesser than NA. So guys, NA is 50, NB is 35. So as you can see here, since NA and NB, one is inside the other, what about the intersection of A and B? If I ask you N, A intersection B is what? So in this case, this entire area would be the intersection, which is what? Which is 35 only. So this can be the maximum value of what? This can be the maximum value of NA intersection B. Okay. So NA intersection B, this is what, guys? This is max, which is 35 in this case. Now, what about the value of NA union B, guys? So if NA union B, from the figure itself, even though we can do it by the formula also, the figure itself, it's quite clear that their union is basically this circle only. So NA intersection B, sorry, NA union B would be 50, which is equal to NA only. So this is what, since NA intersection B is max, NA union B would be what? It would be minimum, guys. Okay. So we can say that from this case, we can say that can we say that the range of NA intersection B is greater than equal to 0 and less than equal to 35? Can we say that? So guys, yes, we can say that, because the max is 35 and the minimum is 0, and in the case when they're intersecting like this, the value of NA intersection B can be between 0 to 35 when they are, you know, related like this, when there is some partial intersection. So that way we can do this. So this is another case. Now guys, let's take another example when NA is given to be 40%, NB is given to be 75%. We have to establish the range, the possible range of NA intersection B, guys. Okay. So this is we have to do. So how we can proceed with this? Now as you can see here, we cannot separate. Can we make NA and NB as disjoint? Is it possible to make the two circles way apart from each other with no intersection? Is it possible? What I mean to ask, is it possible that NA intersection B is 0? What we did in the previous example, is it possible that in this example as well NA intersection B is equal to 0? Now as you can see here, if you draw them apart, guys, like if you draw the figure NA if you add them, okay, if you add them Na plus Nb, you will get more than 100%, guys. So in the previous example, you will get what? 115%, which is not possible because Nu is, we know this area is 100, means this is 100%. So this is not possible. Okay, to draw Na and Nb away from each other, what I mean to say is A and B, A and B are disjoint. A intersection B is equal to phi. Is it possible? So guys, the answer is no, it's not possible. So what we will do, as you can see here, so since it's not possible, then in that case, what we can do, we will try to draw, this NB 75%. Okay, so if you draw, this is, I will draw a line which reflects 75% like this. So this much is NB, which is 75%. Now from here onwards, if I draw Na, okay, this much area which is left is 25% only, but in order to draw from here to here, this much is Nb, guys. Okay, now in order to draw Na, this, what we are left is 25, but for A guys, we must have 40% area. So from here to here, what I mean to say is this much, this rectangle, even if I draw it like this, there will be a minimum intersection like this, where from this area is Na, which is 40%. Okay, so this minimum amount of intersection would be there. So this is 75%, this is 25%, this total is 40%. So this much area, which is 15%, the minimum A intersection B area, it has to be minimum, it has to be 15% only, because we have to take care of Nu equals to 100. Okay, we have to take care of Nu equals to 100. Or else you can also think of like this, that Na intersection B is Na plus Nb minus Na union B. So this is, sorry, this is 75 and this is 25, right? This is 40. So this is 75 and this is 75, this is 40. Just a minute, guys. So Na and Nb 75 plus 40, which is what, guys? Which is 115. So Na union B, we have to, if we maximize it, we know that Na union B at the most can be 100 also. Okay, when, so we have to take this case, guys, when A union B is 100, because otherwise from the Venn diagram this won't be possible, guys. So Na union B we have to take 100. So that way also, using Venn diagram also or using analytically also, we can say that Na intersection B comes out to be 15. So it has to be the least. This is the bare minimum which A intersection B can possibly have. Now, what about the maximum range of Na intersection B for the possible values of 40% and 75% Na and B? So, which figure is possible then? So, yes, guys, it is. So, which is this, guys? Okay. So, as you can see here, the maximum intersection which is A intersection B, and A intersection B is 40, which is equal to NA only. So we can say that A intersection B, so this is the maximum it can have. Okay, the maximum intersection NA intersection B can have is 40. So we can say that NA intersection B range is what? From the minimum it is 15, and from the maximum it is what, guys? 15 less than equal to 40. That is the range of NA intersection B from 15 to 40, guys.